we were just talking about the Dirichlet-Categorical model, and so we wrote down what that meant, and then we saw that the likelihood function and the prior looked very similar, and so when we multiplied them together, the exponents just added, and we got that the posterior distribution on theta was also a Dirichlet, and that implied that Dirichlet is a conjugate prior for the categorical. So we had this nice formula here to display that, to remember that. And then we were looking at this predictive distribution on X given the data. And things went kind of fast here at the end, so I want to explain what happened here. So in general, whenever we have a Dirichlet, maybe I'll have to do a video on Dirichlet distribution to explain all this in more detail. But when we have a Dirichlet, let's say eta is a random variable distributed according to a Dirichlet with parameter beta. So this is just some new thing here. And so beta is, let's say, it's beta 1. We'll make it m again, up to beta m. So these betas are strictly positive for a Dirichlet distribution. And the expected value of eta sub I, the ith one, under this distribution is equal to beta I divided by the sum of all the betas. So let's call that beta 0. So we'll define beta 0 to be the sum as I goes from 1 to m of beta I. And this is just an expression for the we'll prove this. Maybe we can prove this in another video. This is just the expression for the expected value of the ith coordinate. Remember, this is a vector here. This eta is a vector. It's a probability distribution on 1 to m. Whoops. 1 to m. Each of these is non-negative and sums to 1, and they sum to 1. So a Dirichlet distribution is a probability distribution over probability distributions. So that's have to get your head wrapped around that a little bit. Not over arbitrary probability distributions. It's over the the PMFs on 1 through m. In this case, m. And so this is just the expression for the expected value of the ith coordinate of that function. And what we did here when we were deriving this predictive distribution was we had the expected value of x of theta x, which is the x coordinate of the theta vector here, and it's the expected value expected value given d. So this is the expected value under the posterior distribution on theta. That's what this is saying. And the posterior distribution we saw is a Dirichlet with parameter c plus alpha. So the expected value of theta under this, or of theta x under this posterior distribution, we can just use this formula here. And the parameter for the posterior distribution, if we called it beta, so if we called beta c plus alpha, then the expected value of the x coordinate is beta x over beta 0, which is just this right here. Cx plus alpha x over the sum of the betas, in this case, is n plus alpha 0, where alpha 0 is this sum. N is the sum of all the c's, because if we sum all the counts up, so if we sum this over j, then each xi has to be equal to some j, so this is just n. You can check that in more detail if you want, if that wasn't clear. Alright, so I just wanted to explain a little bit more how, where this last step, how this came about. Oh, and one other thing I wanted to mention here is that a way to remember this formula, besides the fact that it's the mean of that coordinate of the posterior of the Dirichlet, is you can think about, if you ignore these alphas here, then this would just be the empirical distribution, or it would be the empirical probability that the new random x, takes that value little x. It would be the empirical probability because that's the number of times we observed little x divided by the total number of points. And so these alphas here, so this is a count vector. These alphas are sometimes referred to as pseudo counts because they behave like counts that, if you had observed some counts before getting your data, then you would of course just add them. They don't have to be integers, but you can remember this by thinking of these alpha parameters in your Dirichlet prior as these sort of pseudo counts, and then under that interpretation, this is just a sort of very natural thing as a sort of empirical probability. So that's just an easy way to remember it.